Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# VB.NET User Group. A little bit about the group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. You can find all the meeting information for past meetings as well as future ones over on meetup.com at the link listed at the bottom of the slide. Big thank you to our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting prizes, which will be given using the evaluation forms. Also, a thank you to the .NET Foundations for sponsoring the Meetup site, and NIS Technologies for recording services. Also like to give a big thank you to Manning.com for a 35% off offer at Manning.com for a selection of books using the discount code MTPCLEC21, and the link will be made available in chat in just a little bit. Some general information, please keep in mind participation is always encouraged, and like I always say, the only stupid question is the one not being asked. So feel free to jump in with any questions you may have in mind. However, when not speaking, kindly ask you to mute your microphone to avoid any background noise. And we always like to keep it casual but organized, meaning jump in with any comments or questions, but at the same time, we need to give enough time for our speaker to go through the slides and the demo. And this presentation is being recorded and will be posted on YouTube in a few short days after the editing. So for tonight's feature presentation, we have David McCarter, and he's going to be talking about everything you wanted to know about disposable types. David's a Microsoft MVP and a C# Corner MVP. He's a solutions architect, consultant, speaker, and author. And he's also the editor-in-chief of .NETtips.com, which is a website for helping software engineers write quality code. And he's also the host of Rockin' the Code World with .NET Dave, which is a show on the internet. And he's also an award-winning photographer for bands, big bands for that matter, such as Queensryche, POD, and Steel Panther, and a variety of others. And as you might have guessed, David loves rock and roll, and hence the sweater for Cheap Trick. And so with that, let me turn it over to Dave.
Welcome to Rock Your Code, everything that every .NET developer needs to know about disposable types. And I might be show a little passion during this session because I'm actually working on this stuff right now at work, and you'll see why. Like Sam said, I'm David McCarter. I'm a Microsoft MVP. I'm a featured writer on C# Corner, and I'm an architect, patent inventor, and photographer, all that cool stuff. There's all my handles and email addresses and everything. If you have any questions you want to ask after, please feel free to email me or contact me on Twitter or LinkedIn. All right, I want to promote my coding standards book. I have the only pure .NET coding standards book out there. It's called Rock Your Code, Coding Standards for Microsoft.NET. It's available on Amazon. I hope you go pick up a copy because every team I start to work on doesn't have any coding standards. And so my book is a great way for you to start off with great coding standards and the common coding standards that are been part of .NET ever since it came out. Almost 21 years ago. Dang. Like Sam said, I'm also the host of Rockin' the Code World with .NET Dave. Each Saturday morning, I have top leaders in the world from all over the world speaking on my show, from the #2 guy in the programming world at Microsoft all the way down. So I hope you check out a show. The next show, we're on hiatus right now for the holidays, but the next show will be on January 7th, and I hope you'll check it out and make it a regular practice because I work really hard on that show. All right, so here's what we're going to talk about today. Opening act. Opening act is always why I'm doing this talk. Memory handling, kind of getting everybody on the same page that we all understand how memory works in .NET. Disposing of disposable types, which is the #1 issue I see developers not doing right in code. And then properly implementing the IDisposable interface, which you'll need to do in certain times. And then using tools to find these issues, and then Encore. And then this talk is about an hour, so if there's time left over at the end, which I'm sure there will be, I'm more than happy to hang out and have you guys answer any questions you want about .NET or programming or the Microsoft MVP program or anything, or music. I'll talk about music all day long. All right, so opening act. I did photography of Horathani. She is one of the best guitarists I've seen in a long time. Okay, anyway, so let's get down to memory handling. One of the great things ever since .NET first came out, over 20 years ago, and I've been working with it ever since 2020. 2000, really. The great thing about .NET is it takes care of most of the memory handling for you, unlike other languages like C++, which were always a problem. And those languages, because of their issues, allowed people to hack into programs written in C++, like Internet Explorer and things like that. So that's virtually kind of impossible in .NET. So all types are, .NET creates types on the memory stack, and we'll talk about that. It creates objects in a memory heap, and we'll talk about that in the next section to make sure everybody's on the same page. And then the ones on the heap destroys the objects when they're no longer in use. Well, they both do, but we'll talk about those differences in the next section. But that's one of the great things about .NET. But this is the number one issue I see. Like I said before, I've reviewed millions of lines of code in as long as I've been programming, and including the new project I'm on right now. And the number one issue I see is developers not calling .dispose or using the using statement for disposable objects. Whenever I start at a new company, and I've been doing mostly contracting for the last 10 years, is after I look at their source code, I go into the manager and I say, so do you have any code on the back end do you have any machines on the back end you just have to reboot every once in a while that you don't understand why? And every single time they say yes. And then every single time I say, I know exactly why. And it's this. It's people not doing this correctly. I see it in every single project I work on. And like I said, I'm actually working on this right now. So 4 weeks tomorrow, I started a brand new contract. And for 4 weeks, I've been working on these issues. And I think I've finally got them all nailed down. And hopefully next week, we'll get that into the main branch. But I've been doing this for the last 4 weeks nonstop. And so like I said, if you aren't doing this correctly, don't feel bad because no one else does either. But it's very, very important. And we'll talk about why. And then the other thing is not properly implementing IDisposable, and it's in types that need to be disposed of, your own custom types that need to be disposed of. So we'll talk about that too. So what this causes, so .NET doesn't have like true memory leaks, but what they have is virtual memory leaks. And what a virtual memory leak basically is that it'll just gobble up the memory until there's none left, and then your servers and your processes stop. Or it'll become so slow that you'll have to reboot your servers. But that's what happens with virtual memory leaks, is it brings down your app or services or your servers if you don't take care of them. And I've been dealing with this ever since the first version of .NET. I learned the hard way in version 1 of .NET of virtual memory leaks. And so I've been really cognizant of that, through my whole career in .NET at least, and try to be 100% no leaks whatsoever in my code. So here's a real world story. This is not my current contract I'm working on right now. My current contract is not as bad as this one, but this is the most extreme story of a project that was really out of control when it came to virtual memory issues. So in just one solution, I found over 600 places where .dispose was not being called where it was supposed to be called. 600. It's the worst I've ever seen in a solution. There were over 90 types, 90, that did not properly implement IDisposable or implement it at all. And 90, I've never seen that in my career. What this caused basically is over 2,000 touch points, meaning 2,000 places in the code I'm going to have to fix. And then that creates another whole issue with, merging and all that stuff. And in this time I worked on this project, I worked I worked on this for over 6 months and I still wasn't done. So this is why, I did this talk, because I want you to do this when you first write your code, because if you don't, you're going to run into these issues later down the road. And I get a bit frustrated because .NET's been around for almost 21 years and people still aren't doing this correctly. Because, when I start working on a new project, I'd rather work on features. I don't want to fix the code that hasn't been written correctly for 5-10 years or whatever. So, all right. So memory handling, let's get everybody on the same page. And, because I know developers don't handle this very well, when I taught at the university here in San Diego, I taught at UCSD for almost 18 years. I drilled this information into my C# beginner students' heads, because I wanted them to leave that class knowing everything about memory handling. Because, the important thing about memory handling in .NET is if you go to an interview, there's probably a really good chance you're going to be asked questions about it. And if you interview in front of me, I will definitely have you explain how the garbage collector works. And if you can't, I probably won't hire you. So unless you're a beginner, then maybe I'll give you a break. So first, let's talk about the memory stack, because we're not really going to focus on the memory stack in this talk. The memory stack is very, very fast. And basically, every type and built-in type in .NET that's basically a number is created on the memory stack. So those are date times, integers, booleans, all those types are created on the stack. And they're very, very fast to be created. And they're removed as soon as you get to the end of the code block, then they're removed out of memory. So they go into memory, they come out of memory very, very fast. So if you're dealing with those types of types, that's great. You don't really need to worry about memory handling with these types, because the issue is really with the garbage collector and reference types. These are value types, the reference types of what we're going to need to worry about. So the memory heap is where all the reference types live, and that's most of the types you're going to be using, at least the types I use in projects. So basically, any type that you use a new and strings, because there's a shortcut for that, is a reference type. And so therefore, all of these types are handled by the memory heap. And this is what we need to be worried about when we're coding. Creating types in the memory heap is very, very fast, because types are always created at the top of the heap. It's not like a hard drive where it has to go in and find holes and plug the holes and things like that. It doesn't work like a hard drive. Everything goes on the top of the heap and up from there. And I'll explain why with some graphics coming up. The objects are removed when by the garbage collector at some point. And usually what I say is when the garbage collector feels like it. You really don't have any control over this. It's really controlled by the garbage collector. There are things that causes the garbage collector to wake up and do this, like memory pressure, or too much stuff in memory and needs to get stuff out, things like that. But generally, you don't have much control over the garbage collector, which probably is a good thing, because the garbage collector has dramatically improved since version 1, and it's a lot better at handling these things, even multi-threaded now, than it was in version 1 of .NET. And then the garbage collector compacts the heap, so everything is created on the top, and I'll show you that in a second. So here are how objects are created. So everything on the object heap, the memory heap, is created in either Gen 0, Gen 1, or Gen 2. most objects are all created in Gen 0, and then the garbage collector or the runtime will move it to the other ones depending how long it thinks it's going to live. But generally, most everything is created at first in Gen 0. So here's an example where I have some objects in Gen 0. I have object 1, 2, 3, and 4. And if I do like a new data table or something like that, then that's created. Object 5 comes along, is created right on top of the heap, and keeps going from there. So that's how you can create, tens of thousands of objects, in .NET in very, very, very little time. It's because the way this works. So how are objects destroyed? That's what we need to worry about. And that's my focus of this talk. So here's some example code. This is, I'm pretty sure it's from my open source project, Spargin. And here's get bytes and memory stream. You can see here is a disposable type. You can see that I have it wrapped around a using statement, which I'll talk about in a little bit, which is the proper way of doing things these days. And so it's newed up in the using statement, which is the proper way of doing things. And as soon as it hits the end of the code block there, right, then what happens is that then that memory stream doesn't have any pointers to it anymore. So that's why I marked it as red. It's basically a dead object living in memory with no pointers to it. So then what happens is the garbage collector wakes up for some reason and wakes up and goes, oh, you've got some objects that aren't being used anymore. So I'm just going to remove those. And that's what it does. It goes through the tree and it finds all the objects without any pointers and removes them out of Gen 0 or whatever generation the type might be in. I'm sorry, not the type, the object might be in. So to show you how, new types are still created, when there's holes like this, is if object 6 comes along, it's just created on top of object 5. It's not created where 2 was. Because 2 at this point actually isn't gone. It's still there. And so it removes the pointer to it. And then once it removes all the pointers, then the garbage collector comes along and then compacts the heap and then starts creating objects on the top there. And we need to be cognizant of the compacts because the compact of the heap can actually suspend your program. So you need to be cognizant of how much is being created and destroyed because it actually can cause performance issues. I haven't seen them as much as I did in the early days of .NET these days, but it can still happen. So we have to be cognizant that we're not making the garbage collector do too much. So I hope everybody understood basically how that works. I did this section because I wanted to get everybody on the same page because unfortunately I've been learning that this stuff isn't taught in classes in a lot of the developers I talk to, and that's why a lot of developers don't know how this works. That's why I do this talk, and that's why I wrote a 3-part series on my website and on C# Corner. All right. Any questions so far, really quick? Okay, no questions. All right. So now the first thing we're going to talk about is disposing of disposable types. This is, like I said, the #1 thing I don't see developers doing, and this is what gets their projects in trouble. So call dispose. So it's critical to call dispose as soon as the type is no longer needed. So here's an example of newing up a string reader. You can see I created a string reader, which is a disposable type. I did some code and then I dispose of it. So you should dispose of these as soon as possible because that allows the garbage collector to get rid of them faster and then improve the performance of your application. But like I said, I'm going to say it over and over. This is what I don't see developers doing. And I'm not really sure why, other than a lack of knowledge, I guess. So how do you know if a type is disposable? Well, of course, if you've used it before, like I have, I know a lot of the types just off the top of my head because I've been doing this for 21 years. And so I'm pretty good at that. Um, in the early days of .NET, what I would do is at the end of the types I didn't know very well, I would always do .d and see if dispose comes up. If it did, then I knew I had to dispose of it. And then later, when the using statement came around, I would just wrap it around the using statement. Because in the beginning, we didn't have the using statement as we do now in C#. Or you can just go look at the definition, and you can see here in this example, you can see the IDisposable interface. So if you look at the definition of the type, see IDisposable, it's disposable, right? So that means it has to be disposed of. So the way we do it now is we just use the using statement in .NET. And you saw this before, but here's an example again where I'm creating a string reader, I'm creating the using, I'm creating the XML serializer, I'm deserializing this XML and returning it. And then, like I said before, as soon as it reaches the end of the code block, dispose, it's automatically called, even if an exception happens. So you don't have to worry about exceptions, because if they do happen, dispose will still be called. And that's why you really should only use the using statement if all possible, because it does still work if there's an exception. Otherwise, you have to write more code. So what does using do? Using just creates a try finally. So if you look at your code in IL, like here, you can see I have a try there. I've got the code. You can see under the try, I have a finally, and then you can see in the finally, you can see where dispose is being called. So that's all using does. Using is just a shortcut to create a try finally. That's it. Before the using statement, we would have to do this ourselves. And so it's just a shortcut to make our lives a bit easier. And I like it better because it creates less code that we have to look at when we're looking at the code. You can see it's still created, in IL, but we don't look at all that try finally stuff. So there are hidden issues that I learned about in my last contract that I didn't finish all of the disposable stuff. And the issue is what you just saw here. When you're calling deserialize and newing up a string reader in the call to deserialize, okay? Bad, because you have absolutely no opportunity to dispose of this type now. So don't ever do this. Always new up the string reader before that call and use a using statement. Never, ever do this. And these are tough to find in code because they're hidden. So all the people who like to put too much code in one line, cut it out, especially when you're dealing with disposable types, because you will shoot yourself in the foot. And these are harder to find, like I said. All right, any questions so far? So that's dispose. Hopefully everybody knows about dispose. Please, when you go to your projects tomorrow or when you're off a holiday, please do what I say in this talk and analyze your code. I know that might cause some work for you, but believe me, everybody will be happy when these things are fixed. And my new boss is really getting happy because he can't wait for these fixes to get put up into the main branch. All right, no questions?
I have a couple of questions for you.
Okay.
So with this slide, the previous slide that you had up with the hidden issue, so you're newing an object on the return, but once you return and that object is no longer needed, isn't the garbage collector going to take care of it when the algorithm kicks it off?
No, the garbage collector won't just. The problem with newing up a string reader like that is that dispose will never be called on it. Okay, because it's not wrapped around a using statement or anything like that. So does that answer your question?
So that object will continue to live for the duration of the application?
No, it will be removed out of memory as long as soon as the garbage collector determines there's no more pointers to it. The problem is when it's removed out of memory, dispose won't be called first. Does that make sense?
So it will be removed out of memory, but dispose won't be called first, is what you're saying.
Right. So what that causes, like for example, if this was like dealing with a database connection, right, that could leave the connection open because dispose wasn't called, because in the dispose is when the connection is closed, right? So whatever resources string reader has to get out, has to clean up a memory won't happen if you do it this way.
I see. Okay.
Yeah.
And then the other question I had for you was in a couple of previous slides, you mentioned that dispose will appear as a method in IntelliSense only when that object is no longer being used. But
No.
let's say,
No,
go ahead.
dispose will appear if it implements IDisposable.
Okay. All right. I misunderstood you then. Okay.
Yeah. So I'm kind of glad you asked about being removed out of memory. So I didn't put it in the slide deck because I have too many slides in here anyway. But so there is a special case where this might get cleaned up, and so I'd have to look at the string reader specifically to find out. But when you implement IDisposable, it doesn't require you to implement a finalizer in your code. So what some people do is they implement a finalizer and they call dispose in the finalizer. So then that will clean up the memory. The problem doing that, and you kind of want to avoid that happening, because what happens is that when the garbage collector is looking at the types to remove out of memory, if it finds a type that has a finalizer, what it does is it go, oh, you have a finalizer. I need to call you, but I'm not going to do that right now. I'm going to put you in this special queue over here. I'm going to continue with my garbage collection and do that. And then after the garbage collection is done, then I'll call dispose on the type. And then that object will still be in memory basically until the next garbage collection. Does that make sense?
Yeah, absolutely.
Yeah, so you kind of want to avoid, two garbage collections to get rid of your type, because that just creates too much memory pressure, right? So you just want to avoid that. Don't ever do that. And you shouldn't really implement finalizers unless you're really, really worried that someone's not going to call dispose. So it's really up to you if you want to do a finalizer or not. I tend to avoid them unless like I said, I'm really worried the memory won't be handled correctly. So does that answer your question?
Yeah, thank you.
Okay, sure. Any other questions? Okay. So I would say 99%, maybe not 90% of the memory issues I see are what I just talked about. The other 10% is what I'm going to talk about now, and that's properly implementing the IDisposable interface, which is very important for your own types, your own user-defined types, basically. So rule: if your type uses a disposable type in a field, it must implement IDisposable, okay? Because that's the only way you're going to dispose of that type, if you implement IDisposable. So the problem is this right here, and this is a real type. This is some real code. I never show fake code. This is real code I found somewhere, and they had a class called PDF Streamer, and they newed up a memory stream in a private field, which is the correct way to do things. You should never have public fields in your types. But the problem is, its memory stream is disposable type. So, one of the hints, any type that ends in stream in the .NET is a disposable type. You can guarantee it'll be a disposable type if it ends in stream. So this object, the memory stream will never be properly disposed of in this case. So we're going to fix it. So first, you need to implement IDisposable. The IDisposable interface has only one method called dispose. It will only have one method called dispose. And this is what you need to implement in your type. But there's like a 3-step process on how to properly code this. And I'm gonna talk about that now. So the first step is, of course, implement IDisposable. So here's an example of a type in my open source project called cached enumerable, and it implements IDisposable along with IEnumerable. So this type needs to be disposed of. Second, create the dispose method. Okay, this is the proper pattern to create the dispose method. I'm going to give you a link to the template that I use for all of my disposable types at the end. And this is part of that template. First, you create a private field, a bool field called disposed, because you can't dispose of a type twice. And then you create a dispose method. If your class is inheritable, if it can be inherited, gosh, you can create a public virtual void. Otherwise, just do a protected virtual void. Otherwise, just do a public void dispose. And it takes in the parameter disposing, which you'll see in a minute. When it hit the first check it does is if it's already been disposed, bail out, because you can't dispose of types twice. That will cause an exception. So you want to bail out of it. So if it is disposing, then you can just do this.stream ? .dispose, and you're all done. Okay. And then you set dispose to true, and that's how you do it. So this is how, and depending how many disposable fields you have in your class, you have to list them all here and dispose of them all. The other thing, especially if you have to go clean up code, and I was doing this on the project I'm working on right now at work. A lot of people, when they new up objects like this, especially streams and database and other objects that have a close method, a lot of people call it close when they're done with it. When you implement the using statement, you really don't need the close or flush methods anymore, because the dispose methods already do that. So you don't need to do it twice, basically. It's just more computer instructions. So that's step 2. Step 3 is to implement IDisposable.dispose. Okay, this is the method that you need to implement that people will call. They don't call the other one, they call this one. And the first thing you do is do dispose true, runs through the dispose process. And then the next thing you do, especially if you have a finalizer in your code, you need to do gc.suppress finalize this. What this does is when the garbage collector looks at your type and says, oh, you have a finalizer, I have to put you in a queue. When you set this will prevent your type from going into that queue and being disposed of right away instead of in the next round. So if you do a finalizer, you need to also implement GC suppress finalizer. It's very, very important. Otherwise, your object will be stuck in memory too long. Okay, so that's the 3-step process on doing that. So because I've been working on so many dispose issues in the last 10 years, I've actually implemented some helper methods in my Spargin project, which you can go get the NuGet packages. I just released a new version at the beginning of November. And this is what I call future proofing. So I created an extension method in my Spargin project called dispose fields. So when you implement dispose, all you need to do is do that, and it will take care of all the fields for you, all the disposable fields in your type. I call this future proofing because if someone like me who really understands dispose and understands memory management creates a type, and then a more junior person comes along and who doesn't maybe understand memory handling as well as the senior people do, and they add a disposable field to the type, it's automatically taken care of because Spargin will figure it out and dispose of it for you. So this is what I use now in any project. I'm using my open source project because it just makes things a lot easier. I created another method. This might not make sense because I've only run into this a few times in the last 10 years. I was working at this one company, and every time a user hit their site, that could possibly spin up 10,000 objects in this collection. I'm not kidding. And all of those objects were disposable, and they weren't disposing of any of them. So they definitely had issues. That's why they hired me, and because they were always having problems on the biggest traffic days of the year, and that's why they hired me. The biggest traffic days of their year was Black Friday and Cyber Monday, and they were always having problems. And their big customers like Nike's and former Toys R Us and companies like that were getting pissed off at them. And it was partially because of this. And so I created a method called dispose collection. And if there's any disposable types in the collection, then this will take care of it. The cool thing with the one thing I did add is if you call dispose fields, it also calls dispose collection, just in case any of those fields holds any disposable items in the collection. And then if you're not using any of those and you want to just get rid of an object right away, you can do try dispose, which just checks for null and disposes of it. It's just a shortcut. So I created these three methods. I don't use the last two very much. But like I said, I use this in all my new code now because, like I said, it helps me future-proof, going on after the type is first created. Okay. Any questions with implementing IDisposable? There are other rules around this, which I don't have time to talk about in this session, and that's when you inherit a disposable type. But if you go read the articles on my website, it explains exactly what to do in that case. Any questions? Nope? Okay. So now we're going to talk about the last section, and that is using tools to find disposable issues. So I could tell you from experience that finding these issues is not super easy. And I've yet, even as of today, able to find a tool that will find everything, unfortunately. There's not one that I am aware of that does. I've researched a lot of different tools and even did analysis on them, and none of them find as many issues as I do. So that's why, I say that your eyes are always still, the best tool that finds these issues. But, these tools can dramatically, speed up the process in doing this. So I rely on these tools to find most of it, but I always have to analyze myself because they don't find everything. So when I was working on that really, really bad project with 900 plus, with 2,000 touch points, I ran all of these analyzers through that project, and these were, all the ones I can find at the time that will find disposable issues for you. A program I've used for many, 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 many years called Code It Right found none. CodeRush, which is the refactoring tool that I use, found none. Independ, which is a really good tool. Only found 72 out of the 900. ReSharper, which is another refactoring tool, I only found 3. SonarLint only found 25. Visual Studio Analyze found none. So unfortunately, you can see these tools aren't very good. But like I said, I found over 700 issues, and this is all they found. They don't use these tools. Just kind of what I'm saying. I've only found one tool that finds most of it. And like I said, there's no tool that I know of finds all of it. The only one that does the best is called it's kind of newer. It's called the IDispose analyzers. It's I forget who it's written by, but this works. It works really well, and it finds a lot of weird disposable issues that we might not think of. It checks, the last time I looked, it checks for 26 disposable issues. So those are the, there's lots of disposable issues you need to be worried about. And this checks for 26 of them. So what I want you to do when you go back to your projects tomorrow or after the holidays, install this in every one of your projects and see what happens. I did this talk in October in India, and live in India. I wasn't virtual, I was there. And I did this talk on the first day of the big conference in Delhi. And someone listened to me, and the next day I was standing out where the booths are and everything. And he walks up to me and goes, "Dave, I implemented the IDisposable analyzer and I found 36 issues." And I go, "Yay!" That's exactly what it's supposed to do. So, so add this to all of your projects. I added to all of my projects in my new company. I added to all the projects except for the test projects, which I'll probably go back and do those too. But add this to all of your projects. To me, this is a requirement. I think .NET should just install this for you. I should talk to them, and the next time I talk, I'm friends with the architect of C#, and we have coffee chats like every quarter. Next time I talk to him, I should talk to him about that. The iDisposable Analyzer is free. It's just a NuGet package. It's free. You can go look at source code if you want to. So totally free. And like I said, it's the best. So make sure you do that tomorrow or after the holidays. And if you do, please email me and let me know how many issues you found. I'd love to know. See if you get more than 700. All right. So even after fixing all the disposable issues, running the iDisposable analyzers against it, fixing all those issues, doing all that stuff, you still might not catch everything. The only way you can find everything, to me, in my mind at least, is to run a memory profiler against the running code. And to near production environment as you can. Since I started doing memory profiling, I don't think I've worked on a single team that actually did it. And some teams I wanted to do it and they refused to pay me for it, so I did it on my own because I think this is super important. And I think teams that release production software without doing this they're really hurting themselves as far as memory and performance goes. So I can't stress this enough. The only way to find all the disposable issues is to run a memory profiler on running code, because all these other analyzers are mostly static code analyzers. They don't look at the code while it's running. And you will find the remaining issues, and you will find tons of other issues too in your code. I found lots of issues with memory profiling. If you haven't done memory profiling before, make sure you allocate a lot of time to not only run the tests, but then even more time to analyze the tests. The only drawback to the memory profiling is it takes a lot of time to look at the final report. and to figure out what you can actually work on, because a lot of the stuff it finds is actually problems in .NET itself. And I've even brought issues to the team because I found them. I think the first one I found was in some kind of HTTP object a long time ago. So I can't stress this enough. Oh, I thought I had some, yeah, I do have some slides coming up. So I actually did a poll, and you can see here, most people don't do memory profiling. 60% don't do it basically. So I think that's a problem. So the memory profiling tool that I prefer, I've tried most of them out there, including from Redgate. The one I like the most is called the .NET Memory Profiler from SciTech Software. It's not very expensive at all. It's only, the last time I looked, it was under $300, and it'll pay for itself the very first time you use it. And not everybody on the team needs it, right? Only the person or people on the team that really understand this stuff need this. It shouldn't really be a part of every developer's practice, because that will really eat up a lot of time. You should really designate really only one person, maybe two, as a backup to do this kind of stuff. So you only need a couple copies of .NET Memory Profiler. And I didn't do a graph on what it looks like when you're running the test. Oh yeah, this is what it looks like when you're running the test. You can see live, how much is in memory, how many bytes are being held, how many bytes are pinned, which is bad. It shows you when the garbage collections happen. You can take memory dumps whenever you want. You can actually, what I prefer to do actually is I time the memory dumps every so often, so it does it, so I can use those for comparison. But I like this one the best, and it's easiest to use. It has all the bells and whistles. It does basically any kind of .NET project there is, including ASP.NET, and so I really do like it. Once you run it, this is the report you'll look at the end, and you can see here's some disposed instances. There's some other undisposed instances right underneath it. And there's lots of other things in here too besides disposable issues. But for this talk, I'm only looking at disposable stuff. So here, this is where I would drill in it. You can see right under, I don't know if you can see my mouse, but right under where it says disposed instances, it tells you the types that have the issue, and then you can drill into those types and figure out what's going on. And one thing I do like about .NET Memory Profiler, I feel like I should get paid for promoting this thing, is this right here, this graph where you can follow the code all the way up into where it happened. And this is a really valuable graph when you're trying to pinpoint where things really happen. And one thing I don't do this all the time because it eats up a lot of memory, but at least one run, what I do in the memory profiling is I also have it gather all the data that's held in those types. So you can drill all the way up to where the issue is. You can see the type, and you can see what the data values were in that type to help you figure out maybe what's happening and why you're having a disposable issue in that type. So I really like this view because it helps me to drill down on the actual issue. And this is where I found issues in .NET the .NET framework I brought back to the team. This is not a talk about memory profiling, but I can't stress this enough. I haven't really written any articles about it. I just talk about it in conference talks, but you need to do this on your production code. I guarantee you it'll be a lot better off if you do. Because it also helps with performance. It tells you you're holding too many strings in memory and all kinds of really cool stuff. Anyway, any questions? Nope. Okay. Encore. Oh, got that show. Okay. Got a couple odds and ends just to talk about before you finish up and do Q&A if you have any questions for anything else. Avoid static fields. static fields are bad, bad, bad for a lot of reasons, including for disposable stuff. Try to avoid them. And like I said, you are the best tool to find disposable issues. Like I said, use tools to help speed up that journey, but it's still down to you. And like I said, I actually found, I think a couple of days ago in this code base, a couple disposable problems that the IDisposable analyzers didn't find. So again, it's still, a lot of it still relies on you. All right, I'm almost done. Here are links to more information. Of course, you can go to the first link to buy any of my books. And I was talking with Sam about this. I just ordered the preview, the proof edition of the proof copy of the third edition of my code performance book. I'm so happy it's done finally. I've been working on it for most of the year, really, really hard. And so that will be coming out the beginning of the year. But you can get all my other books going to that link. This talk is actually based on this 3-part series articles that I wrote on my website and on C# Corner. So that's the link to the first one, and I hope you'll follow the rest of it. So basically everything I've just said is in those articles pretty much. If you want to check out my open source project, go to the link there for Spargin. And then if you want to use my IDisposable template for when you implement IDisposable, you can go to the final link there. That's what I use. I go to that on my own link when I'm working on other projects, and that's the template I use when I'm implementing the IDisposable interface. Okay, and that's it. Thanks for attending, and there's more links there. There's my handle, there's my Twitter, my LinkedIn. Please feel free to contact me if you have any questions about this or memory handling or performance or anything else. So that's it.
Excellent. Thanks a lot, Dave. Appreciate it.
So do you want to do Q&A now if anybody has any questions about anything?
I was just about to ask, any questions or comments from anyone?
I'm curious, since you said that these memory leaks, end up being behind a lot of like having to reset applications, is there like kind of like an easy telltale sign like when this happens to know it's kind of a memory leak versus something else? I mean, our applications are just deployed on IIS, so I was curious if it shows up like in the app pools or some other place, or does it just kind of depend?
Well, if you want to see if your app is headed down that road or already down that road, one of the easiest ways, and this is actually the way I did it in the very beginning of .NET, is just run one of the Windows profilers against your app. So .NET has built into it a ton of Windows profilers that you can look at memory, you can look at I/O, you can look at SQL calls. There's tons of it, and so what you could do is basically you can use the Windows profiler, target that IIS process, and then you can watch it. And you can usually, what I did in the old days before I had memory profilers is I would like run that for a long period of time, have it write out to a file every so often. And if you see the memory heap basically just going up and up and up and up and up and up like that and never coming down, then you have a memory leak, right? Because in .NET, when you're creating memory, and if you're looking at it in like a memory profiler or something like that, you're going to have peaks and valleys and stuff like that, but they should be peaks and valleys. It should go up, but then it should go back down, go up, go back down. It should be a basic level for most of the run, right? But if you see it going up and then not all the way back down and then up and then not all the way back down, then up again, then you have a memory leak. Does that make sense?
Yep, yeah. I'll have a look at
But
that. Nice.
yeah, if you haven't used the Windows Profiler, it's really simple to use. You just have to go in there. You have to find the .NET stuff and just point it to your running application, whether it's ASP.NET or whatever else, basically, and just watch it, you know, and see what happens. But the best way is just to run the memory profiler against it, and then you will see immediately what's going on, pretty much. And there's actually, there's one built into Visual Studio too. So if you don't want to buy the SciTech one, you can use the one in Visual Studio. I don't use that one because to me, it's to me it's a subversion of the .NET Memory Profiler. So I really don't use that one, but you can use the one in Visual Studio. Yeah. And that one keeps getting better, but the one from SciTech is still better. So. Any other questions about that or anything else? Nobody wants to be in a Microsoft MVP?
So tell us about that. What does it take to be a Microsoft MVP, and what are the benefits?
Yeah, so becoming an MVP is pretty tough. It's a kind of a grueling process. And basically, in a nutshell, if you put it down to one sentence, the MVP program rewards, experts in their field, mostly for the community work that they've done. We're basically ambassadors for Microsoft, and we help people on behalf of Microsoft. So, the first thing is you have to get nominated, and there's a couple ways to do that. When I started, you couldn't nominate yourself, I think. You could either get nominated by somebody at Microsoft, which was my case, or you could get nominated by another MVP, and then you could go into the process. Now I think you can nominate yourself, but I think it would still go better if you get somebody else to nominate you for you. I didn't even know someone nominated me until I got the call from Microsoft, did it behind my back. And then you go through this grueling process, proving that not only are you're an expert in your field, but you're also do a lot of community work, right? And the community work can be anything from like what Sam's doing, running this user group, participating on forums, writing books, writing blogs, speaking at conferences. It's basically how many people you touch a year is what Microsoft is interested in. And we have to report this throughout the year to Microsoft. Basically, everything I do, I have to report to them. Yep. And then every year, what happens is that, once you get it, you just don't have it forever. It's not like the Supreme Court, right? You actually are reevaluated every single year to make sure you're still doing what Microsoft wants you to do, and then you get re-awarded. So I get re-awarded every the beginning of every July, I think, or every June. I always forget now because I keep changing it. But yeah, we have to go through this process. It's not as bad as the first time, but we have to go through this process every year, proving, to Microsoft we're still an MVP, and you get awarded on basically the technology that you're an expert in. I'm an expert, according to them, in developer technologies. There's basically an MVP program for almost everything at Microsoft, whether it's Xbox or Visual Studio or Outlook or whatever. There's MVPs for. And so the benefits is, of course, you get a lot of great recognition because it's really hard to be in this program. It's to me, it's much better than getting a certification because Microsoft is basically vouching for you. So I use that to my advantage. For example, I legally applied to use the MVP logo in my books, in my slides, in my resume. I had to legally apply to do that. You just can't do it. And so that's a really great benefit. It helps me sell books and help me sell myself and things like that. Another benefit is that I don't pay for any software. Even non-Microsoft software I don't pay for. And I don't pay for books either. All I do is contact the companies, tell them I'm an MVP, and they send me whatever I want. So that's a really great benefit to save money. But that also allows me to try a lot of different things and write articles about it too. So that's really great. I even got Adobe to give me Adobe Cloud for free for 3 years. And they didn't really want to at first, but I kind of kept pestering them, and they finally did it for like 3 years, which now I have to pay for. And it's freaking expensive. The other benefit, and one of the benefits I really like, and I'm not sure if this is ever going to happen anymore because COVID has changed the world, but once a year, at Microsoft, they had what they call the MVP Summit. And it's once a year. It lasts about a week, 4 days or so, depending. And basically all the MVPs from all over the world come to Microsoft, Redmond, every year. And we learn basically stuff we can't talk about. So there's a lot of stuff that you know about that I knew about many years before you did, because we are all under NDA. And to me, that conference is the best one there is, because not only do I get to learn about stuff that's coming down the pike, but I get to talk to, Scott Guthrie and, Scott Hanselman and Mads Torgerson. I could talk to anybody on the Microsoft teams I want. We go out and have dinner with them. We have a party sometimes with them. And so not only do I learn a lot, but one of my favorite parts of being an MVP, you could take the software away from it. I don't care about that stuff really. What I really love about the MVP program is I have real impact on the technology that I'm an MVP for. Like, there are features in Visual Studio that are my idea, right? And we have that kind of impact. And also, being an MVP, I can reach into Microsoft immediately and get help, right? Without going through tech support or any of their other weird pay things. I can email people on the team, and I do. And I get an answer pretty quickly. I can email everybody to Scott Guthrie. I did once. I was working at this company, and I was asking them why they weren't looking in Azure. And the lead developer said because they weren't getting any love from Microsoft. I immediately emailed Scott Guthrie. The next day, we had 2 managers at Microsoft talking to her on the phone, right? So it also helps my projects at work, because I can reach those people and get answers that nobody knows about except for those people on the team. So to me, that's my favorite part, is actually interacting with the .NET team themselves, Visual Studio team, and having real impact on making the product better and making the language better. That's what I've been striving for over 17 years in the MVP program, is to make our world, better. And that's what I love about the program.
Nice. What about the C# MVP program? What's involved there?
Oh, on C# Corner?
Yeah.
That's basically for people that either participate, they write a bunch of articles for them, which I'm one of the few featured writers on C# Corner. I just looked this morning, I'm up to 1.4 million reads there. And it's just for your, involvement in the C# Corner community, basically. Yeah. And so every year I get reawarded on that one too. It's really for the people in India, to give them recognition. I mean, I get it because I'm a featured writer, but it's really for the people in India that write for that platform. And they have even when I was there in October, they have a special MVP dinner where they give away prizes and, awards and, things like that, and an open bar, which is nice this time because the other events didn't have that. So yeah, it's just a recognition for your work on C# Corner. Yeah, and C# Corner is a great, if you write articles, it's a great place to get a lot of reads. That's why I publish on there along with my website, because I get a lot more reads on C# Corner, because they have 6 million people a month hit that site. It's probably the largest non-Microsoft site out there, I think.
Certainly one of the biggest.
Yeah, yeah. Mahesh has been doing that for since the beginning of 2000, um, and I see Mahesh is the guy who runs C Sharp Corner, and his son just got his basketball scholarship to USD here in San Diego, and he's some basketball wizard, and I mean basketball star, and so now I get to see Mahesh more than once a year because he comes out to see his son play basketball. He was out here a little while ago, and he took us all out to pizza dinner. Um, but yeah, it's a great C Sharp Corner is a great community, and especially because it's so freaking big. We get a lot of hits, and those hits help me keep my MVP, right?
Yeah, of course. Right.
I kind of need C Sharp Corner now because it helps me keep my award. So I'll be up for beginning of the years. They'll start looking at us again. And then I get reawarded in June or July. I forget nowadays.
Okay, very good. Any other questions for Dave? All right, if not, I have some concluding slides, and if I may, I'll take the screen back.
Sure.
All right, so in the chat, I just pasted a few links, and they are some things that we'll be covering in just a little bit. First and foremost, the YouTube. The recording of the presentation will be edited and uploaded in a few short days. So if you would please subscribe to the channel to get upload notifications. And like I said, the link for that is in the chat window. The tech events that we'll cover in just a second, those are posted on my blog, samnasser.blogspot.com. And again, if you subscribe to that, you can get updates as things are posted. And last but not least, the feedback evaluation, so we can provide David with some feedback on the presentation for today. In addition, that form will be used to raffle off the prizes that we have from PostSharp and DevExpress. If you joined us after the start of the meeting, I'd like to mention again the special offer we have from Manning.com, 35% off at the URL offered at the bottom. And the discount code is MTPCLEC21. So feel free to check them out. As for technical events, the beginning of the year, January 3rd, which is the first Tuesday of every month, is the Ohio North Database Training User Group. And they're going to be meeting both online and in person. And you can attend that presentation. They're going to be discussing new developer features in SQL Server. On January 11th, which is the second Wednesday, is the Azure Cleveland User Group. And that's also available on meetup.com. And on January 26th is the Cleveland C# VB.NET User Group. And for that meeting, we're going to have Matt Storgerson joining us along with Dustin Campbell, and they're going to be discussing C# 11. And if you're in the Northeast Ohio area, or if you'd like to travel there in January, from the 10th through the 13th, will be CodeMash. And that is a huge conference that attracts developers as well as a lot of the development team from Microsoft. So highly encourage you to attend that conference. We always like to discuss job openings. So TechSystems always has job openings available at techsystems.com/IT-jobs. In addition, always like to ask who's hiring and who's looking for work. If you're in either of those categories, feel free to make yourself known or post it into chat, or you can email me afterwards. And speaking of which, my contact information, snasser@nistechnologies.com. You can also find me on Twitter under my full name, Sam Nasser, and my blog, as I mentioned earlier. And if we're not connected on LinkedIn, I invite you to do so. So with that, thanks again to Dave, and thank you all for attending. Hope you all have a Merry Christmas and a very Happy New Year, and look forward to seeing you all next year. Good night, everyone.